In this video, I am going to discuss about electric field as gradient of the electric potential, and this one is also called relation between E and V. And in previous video, already I have discussed about the potential gradient, where potential gradient is change in potential with respect to distance, which is given by dV upon dr. So let us consider a point charge plus Q which is placed at O, and A and B are 2 points at distance r, and distance between A and B is dr. So distance of point A from charge plus Q is r, and distance of point B from charge plus Q is r plus dr, where distance between A and B is dr, which is very small. And suppose the electric field due to this charge plus Q is E, which is along x-axis. Suppose the electric field due to this charge plus Q at point B is E. Electric field due to this charge plus Q at point B is suppose E. And when we place a test charge plus Q naught at point B, then due to this electric field E, this charge plus Q naught, we experience a force, and that force is F. And the magnitude of that force is Q naught E. And the direction of this force is same as the direction of the electric field. It means this charge plus Q naught, which placed at point B, where the electric field due to this charge plus Q is E, we experience a force F, which is given by F is equal to Q naught E. And when this charge plus Q naught be displaced from B to A, it means when it displaces through distance dr from B to A against this force, then the work done in this process dW is equal to F into dr into cos 180 degree. You know, if the force W is equal to force into displacement into cos theta, where theta is the angle between force and displacement. Here force experienced by this test charge plus Q naught is F. Displacement is from B to A through a distance dr, and angle between them is how much here? 180 degree. So what is the work done in bringing the test charge from B to A? That work done is dW, which is given by F into dr into cos 180, and finally you can write dW is equal to minus F into dr. Let V and V minus dV is the potential at A and B due to the charge plus Q. It means due to this charge plus Q, suppose potential at point A is V, and due to the same charge plus Q, potential at point B is less than V, because this point B is far from A, also you can say far from charge. So as we go away from the source charge, and if the source charge be positive, then the electric potential is decreases. So suppose at the point A, if the potential due to charge plus Q is V, so at point B, potential due to this charge plus Q be less than V, so suppose that potential is V minus dV. So from equation 1, dW is equal to, at place of F, we can write here Q naught E, so minus Q naught E into dr. And from here you can say dW upon Q naught is equal to minus E into dr. Here dW is work done in bringing the test charge from B to A, and Q naught is magnitude of the test charge. So by definition, dW upon Q naught is the potential difference between A and B, between these 2 points. It means by definition dw upon q naught. This is equal to the potential difference between A and B. It means potential at A, which is V, minus potential at B, and potential at B you have taken here V minus dV. So you can write V minus V minus dV. And this dw upon q naught you can write is equal to V minus V plus dV. So this one is cancelled by this. You can write this is equal to dV. So simply now at place of dw upon q naught you can write dV. So dV is equal to at place of dw upon q naught, dV is equal to minus E into dr, or you can say E is equal to minus dV upon dr. It means electric field is the negative of dV upon dr, means potential gradient. So simply you can say electric field is equal to negative of electric potential gradient, or simply electric field is negative of the potential gradient. And here negative sign indicates that as we move in the direction of electric field, then electric potential is decreases. So here magnitude of potential gradient is dV upon dr, and negative sign indicates only what? As we move in the direction of electric field, then electric potential is decreases. And now if we will take the two plates, suppose these two plates, and the potential of the first plate is V1, on the second plate is V2. So electric line of forces will go from positive to negative. So the electric field between this plate E is given by E is equal to what is the potential difference between these two, means change in potential V1 minus V2, and what is the distance between them? D. So you can write here E is equal to V1 minus V2 by D. Or simply you can say if A and B are 2 points and potential difference between them is V, distance between them is D, then you can write here E is equal to V by D. It means the magnitude of this electric field is the ratio of the potential difference and divided by the distance between these 2 points. This is the relation between E and V, or simply you can say electric field as the gradient of the electric potential. As we know, E is equal to minus dV upon dr. Suppose in this electric field, suppose A, B, C are 3 points, and if anybody asks to you what is the potential at point A, B and C, or at which point the potential will be more and at which point the potential will be less, or write down the potential at point A, B and C. So you can say here at point A, as we go or as we move in the direction of electric field, then electric potential decreases. It means as we move from A to C, then potential is decreases. It means at point A potential is maximum, then B and then C. So potential at A is maximum and potential at C is what here minimum. This shows here what as we move in the direction of the electric field, then electric potential is decreases. Importance of the relation between electric field and electric potential. You know, if a charge plus Q, source charge plus Q, and P be a point at distance r from it, then electric potential at point P is given by V is equal to 1 upon 4 pi epsilon naught Q by R. If anybody asks to you, how can we derive the electric field due to this charge plus Q at point P? So by using this relation, E is equal to minus dV upon dr, we can easily find the electric potential due to this charge plus Q at point R if you know the potential due to this charge plus Q at point P. And you know the potential due to this charge plus Q at point P is suppose V is equal to 1 upon 4 pi epsilon naught Q by R. So by using these two relations, we can find electric field due to this charge plus Q at point P. So simply you can say here E is equal to minus d dr, and at place of V write down whole this term 1 upon 4 pi epsilon naught q by r. And here this one is minus 1 upon 4 pi epsilon into q is constant, take outside, so you can see here q upon 4 pi epsilon naught you take outside, and here d dr of 1 upon r. And you know differentiation d dx of x to the power n is equal to n x to the power n minus 1. Similarly, if d dr of 1 by r, we can write this is equal to d dr of r to the power minus 1, which is equal to minus 1 r to the power minus 1 into minus 1. It means you can write this one is minus 1 into r to the power minus 2, or simply minus 1 upon r square. So at place of ddr 1 upon r, you can write minus q upon 4 pi epsilon naught, and here minus 1 upon r square. And finally you can say this is equal to minus 1 minus into minus plus 1 upon 4 pi epsilon naught q by r square. And you know electric field due to a point charge at distance r from it is given by 1 upon 4 pi epsilon naught q by r square. It means by using this formula E is equal to minus dV upon dr, easily you can calculate the electric field at any point if the electric potential at that point is known. So dear student, today you revise this topic here, and in next video I will be discuss the electric potential energy of the system of charges. Thank you.